everybody. Today I'll be talking about the impact of symbiosis. Impact of symbiosis is a very broad subject, so keep that in mind that I will not be able to talk about everything. So I'll be skimming over some points here and there. So let's get started. So there is three different types of symbiosis: parasitism, communalism, and then mutualism. And I will go over all three of them and show examples. Okay, so the first one we're going to go over is parasitism. This is where one organism benefits from the relationship while the other one is either harmed or killed by the relationship. So in the first picture of here, we got the caterpillar, which has been infected by the pesticidal wasp. And this is, you can see that this is that's when the wasp injects its larvae into the host, and the larvae will eventually grow and eat their way out of the host. And even in their dying breath, the host will protect the larvae from other parasitoid wasps. And then on this other picture, this happy grinning little isotope, it is a parasite to fishes. So they will crawl in through the gills of the fish undetected, and then they will make their way to the tongue, which they will eventually eat and replace the tongue. And then whatever the fish eats, it's pretty much feeding this little critter. And then the waste of this little isotope is what's keeping the host alive, but barely alive. So on this one, we're talking about cannibalism. This is a relationship between the shark and the remora. The remora you will be seeing a lot near sharks. They are usually attached to a shark, either on the side or the underbelly, using the suction cup that they have developed on their heads. The shark would pretty much hunt down a prey and then consume it, but whatever bits and pieces of it, those remora will be consuming it. And they, of course, use it as free transportation and protection from other predators. And then the shark is also willingly letting them hitch a ride, because they not only keep them company, they kind of help eat the parasites that are on the shark's skin, which would have ended up irritating and damaging it. Most sharks are willingly to slow down and actually put themselves out there to let them hitch on, but there are few that would that doesn't really like the relationship that they have with remoras, such as sandbar sharks and lemon sharks. And another cannibalism relationship is between the microlid frogs and tarantula. The tarantulas, they are known to eat the frogs, but for some reason they are not eating the microlids. And this instance was first published by Crowcraft and Hambler in 1989. They were actually kind of confused what's going on, because typically a spider that size, the size, could easily consume the little like frog that you see in this little picture. But there has been research done, and they assume that it is a certain chemical cues or pheromone in the frog that they can recognize if they are food or friend. Typically, the frogs usually have some sort of toxin on them, but and they can sense it. So the spider would usually pick up the frog and then pretty much like sniff it as it rotates it in their tarantula limbs. And then if they don't sense that chemical, that frog is food. And if they do sense that chemical, they will put the frog down and then let it go on its merry way. Jolene Kaskany in 2002 did an experiment to see if by placing the skin of the spider's frog, which is like their friend, on another frog that would usually commonly be like their diet, to see if it would be camouflage for the commonly eaten frog. And they tested out, and then the end result leading that the spider would pick up the chemical cues of his friendly frog, the friend's frog. So it ended up examining the common camouflage frog, smell it, and then release it after sensing the chemical cues of a friend. And then the little frog, in return, it actually helps. They eat the ants that would initially eat the spider's eggs. So actually, the frog helps take care of the parasites that are in the spider's nest, and the spider provide it protection and leftover food from its last meal. And then another example of communalism is the jellyfishes. They are used as transport for fishes. So for protection and transport, and the jellyfishes in turn use them as bait to catch food. As long as the fish doesn't mind the stinger, they can stay. Another example would be an anemone and a clownfish. So the anemone would protect the clownfish, and then the clownfish will keep the anemone clean. My last and final relationship is mutualism. So this is a badger and the coyote. They work together to hunt squirrels. Badgers usually go underground to chase out the squirrels from the tunnels by blocking off exit routes, and the coyotes will be above ground waiting for the squirrel to come up. They usually team up during when there's like a decent population of both badgers and coyotes. Sometimes you'll see 2 or more coyotes team up with like a badger. So it benefits both of them by eating more and working less. So it works out pretty well because but not for the squirrel, because the squirrel, to avoid the coyotes, they usually hide in the tunnels. But in the tunnels, the badger is waiting and blocked off all exit. So in order to avoid the badger, the squirrel has to come above ground where the coyote is. So there really is no escape for the squirrel. Another example that's commonly used in mutualism is the plover bird and the crocodile. So in this situation, both organism benefits from this interaction. So the crocodile is known for its powerful jaws that could clamp down with immense force. They're not usually once you clamp down, usually it's really hard to get it open. But when they are above shore, you see a crocodile open his mouth, and if there is a pulver bird nearby, it would hop along into the mouth to help clean its teeth, like pretty much like a dentist in a way, to help that's stuck in between the crocodile's teeth in order to prevent decay and irritation of the teeth of the crocodile. Here's a link to a short little clip that kind of showcase like the relationship between the crocodile and the Egyptian pulver. And another example would be the sea turtle and the crab. So the sea turtles usually grows a lot of barnacles, algae, and like other little organisms that would typically damage their shell. The crab, that's where the crabs come in. It actually help, it eats away some of the algae and like little other critters, organisms, and clear away the barnacles in order to keep the turtle healthy. And they usually live near their bum, where I guess the turtle's waste is another source of food for the little crabs. Another example that I don't have a picture on here is the sunfish. Sunfishes have been recently found out that they would come up to the surface and then they would lay flat, which lay on their side, and then allow birds to come pick off parasites and other debris so that they don't end up like damaging or irritating their skin, which is like really interesting. And then another mutualistic relationship will be the goby and the pistol shrimp. The goby and pistol shrimp are two different species that coexist together in the same hole that the shrimp dug. There are more than 120 species of gobies that are seen to room up with the shrimps. Shrimps naturally have really horrible eyesight, so them by themselves, they would have a hard time keeping an eye out for predators and digging and searching for food. So that's where the goby comes in and help the shrimp keep a lookout, since most of their life the goby is naturally shy and tends to hide anyway. So the goby would use its excellent eyesight to use as a lookout as the pistol shrimp is out looking for food or digging. So if there's a predator coming, the goby would whip its tail to let the shrimp know there is a predator nearby, so come back into the hole. And then the shrimp would, to keep its presence known, they would use their antennas to touch the goby every now and then to bond. And the gobies, they use the shrimps' burrow for mating. So it actually benefits the goby, increases the potential for it finding a mate. And they do end up increasing and sharing rooming with the mate, the goby's mate, and so you'll see like either 2 or 3 gobies and shrimp or 2 together, holed up in the same hole, which is a common sight. And that is all I have for y'all today.